So I want to first make sure you remember what I talked about yesterday. We remember that when we're dealing with a unit circle, sine is the y-coordinate of any point. And if it is representing the y-coordinate of any point, then sine is positive where y is positive, and sine is negative where y is negative. The reciprocal of sine, which is cosecant theta, will have the same exact positive negativeness within each quadrant. Cosine represents x in a unit circle. X is positive when you are on the right side of the y-axis, negative when you are on the left side of the y-axis. And the reciprocal of cosine is secant theta. So this right here tells you where both cosine and secant are positive and negative based on where the angle lands. And then finally, tangent is sine over cosine, which means that it is y over x. So anywhere that x and y are the same sign, tangent comes out positive. Anywhere they are opposite signed, tangent shows up negative. And the reciprocal of tangent is cotangent. It has the same positive and negative quadrants. Now, what I'm going to talk about for these first two examples is if you've ever heard about reference triangles, what I've explained to you about the positive negativeness within each quadrant allows you to not have to worry about how to set up a reference triangle. So what you're going to do with problems like 1 and 2 is you're given enough information to determine which quadrant you are in. So know that the first order of business with these kinds of problems is what quadrant are you in? Is it 1, 2, 3, or 4? And what you can do is you can take a moment to think. Sine is a positive number. Sine is positive where y is positive. That means we're dealing with either quadrant 1 or quadrant 2. Then I have this extra piece of information that tells me that my tangent is negative. And my tangent is negative in quadrants 2 and 4. So if I need my sine to be positive and my tangent to be negative, I must be in quadrant 2. Once you know what quadrant you are in, you know the positive negative sign of all of your trig functions. So what I'm going to do is I'm going to write down all 6 trig functions, including the one that's given. That means we have our SOHCAHTOA, and we have the reciprocals of our SOHCAHTOA. So reciprocal of sine is cosecant, reciprocal of cosine is secant, reciprocal of tangent is cotangent. If we can find out what our SOHCAHTOA is equal to find the other 3, all we have to do is reciprocate, and that's it. Now, I know that my sine is equal to a positive 2 over 5. If I am in quadrant 2, Then when I turn to cosine, I think about x, and x is negative if I am in quadrant 2. So I'm going to put a negative sign here. Now, we were told at the beginning that tangent was negative, so we already have that information. Really, the issue with finding which quadrant you were in was just so you could get a correct negative sign for cosine, which will in turn allow secant to have the correct sign associated with it. Now, I'm going to finish my SOHCAHTOA, and I'm going to do that without using a reference triangle because I don't need to. If I know what quadrant I am in, then I know what sign everybody is, and I can focus on just positive sides only. If sine of theta is equal to 2 divided by 5, then one way that I can create a right triangle is to have the opposite side be length positive 2, and the hypotenuse side to be positive 5. So what you're going to do is remember that sine is opposite over hypotenuse and make a right triangle. But if you don't have to go into a reference triangle, you don't have to worry about positives and negatives. You just stick with positives. Now, if you know two sides of a right triangle, you can find the third side using Pythagorean theorem. So I'm going to put down the letter A. We need to find A. Using Pythagorean theorem, a squared plus 2 squared is equal to 5 squared. It's always leg squared plus leg squared equals hypotenuse squared. That means that I have a squared plus 4 equals 25. Subtracting 4 gives me that a squared is 21. And then we take the square root. And since we're just going to deal with positive numbers, we don't worry about whether it's the plus or the minus, it's just the plus. The square root of 21 is not able to be simplified. 21 is 7 times 3, so there aren't any perfect square factors that I can pull out of that. So what I'm going to do now is I'm going to erase my work down here for Pythagorean theorem. And I'm going to erase my a, and I'm going to replace it with the square root of 21. And now I am going to be able to finish my SOHCAHTOA by realizing that cosine is adjacent over hypotenuse and tangent is opposite over adjacent. Adjacent side is the square root of 21. The hypotenuse is 5. And I have my cosine of theta based on the given information. And then tangent being opposite over adjacent is 2 over root 21. And what I want you to see is that I did not concern myself with positive or negative once I determined the quadrant I was in and identified with my SOHCAHTOA who was positive and who was negative. Then I just did the sides of a right triangle and the knowledge of, again, SOHCAHTOA, sine being opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent being opposite over adjacent. For the other three, all I need to do is reciprocate. That's it. if you know who is the reciprocal of who, you don't have to calculate any further. So now for final answers, cosecant is sine's reciprocal. Positive 2/5 becomes positive 5/2. Secant is cosine's reciprocal. Cosine is negative root 21 over 5. Secant is negative 5 over root 21. And then the reciprocal of tangent is negative root 21 over 2. So when I find the reciprocal, I don't change whether it's positive or negative, but I swap numerator denominator. And then I'm done. That whole problem is done. Now, just so you're aware, when if you are asked to do reference triangles with a problem where you are given that the sine is equal to 2/5 and your tangent is negative, you start off by knowing that your sine is positive. So you know that you're dealing with your quadrant 1 or 3. You still have to go through the process of realizing that when tangent is negative, that puts you in this quadrant. But then if you use a reference triangle, what you're expected to do is use the x-axis as one side of your angle, and the other side of your angle is going to be in the quadrant that is stated. And I'm not drawing the perfect triangle here. And then I drop this down and it's perpendicular. And then I use this reference angle. Now, the hypotenuse is always going to be written as a positive number. You are given that your sine is equal to 2 divided by 5. So you would have to look at this and go, 2 is opposite side, 5 is hypotenuse. Let the hypotenuse be positive, but you then have to determine whether you are dealing with a positive y or not. And then for the x, you have to realize that it's negative, so you put a negative there. Then you've got to still go through Pythagorean Theorem, and you'll get the square root of 21. But from there, you would have your 3 sides. And then you can go about saying what all 6 of your trig functions are. You were given at the beginning, just to point it out, you were given that the sine of theta was equal to 2 over 5. Once you've made this triangle, cosine is equal to the adjacent side over hypotenuse, and the adjacent side is negative. And tangent is equal to opposite over adjacent. Opposite is a positive 2, adjacent is a negative root 21. From there, again, the other 3 are just reciprocals. So I just want you to see a little bit of, if you were asked to use the reference angles, this is what it's referring to. But the amount of work you have to put into it, you already have to figure out what quadrant am I in. And so I find it easiest to just take note of who's positive and negative, what quadrant am I in, and then not worry about how do I draw my triangle, where am I supposed to position it correctly, because people forget that you're supposed to always, with a reference triangle, use the x-axis to make one of the sides of your angle. So that means your reference triangles are either the one you see here, or this, or this, or this, and those make up your possible 4 reference triangles. But again, do things however you want to do them. You may be learning from someone teaching you trig, and they may use the reference triangles, and then you feel comfortable with them. So it doesn't matter how you do it, just that you find a way that is correct, but most importantly, that it makes sense to you as best that it can. So that's problem number 1 done. I'm going to erase it, and then we're going to work on problem number 2. This time we're given what secant is equal to. Secant is a negative number. For me, what I do is I think, who is secant's reciprocal? This is the reciprocal of cosine. So I am dealing with cosine being negative. And if I think about my 4 quadrants, my x-coordinate is negative if I am in quadrants 2 or 3. Then I'm told that I have a positive value for sine. Sine is positive in quadrants 1 and 2. So we coincidentally are in quadrant 2 again. And now what I'm going to do next is write down SOHCAHTOA. In other words, sine theta, cosine theta, tangent theta. Cosine is secant's reciprocal, so I immediately know that my cosine is negative 4 over 7. I'm told that my sine is positive, so I'm just going to put a plus sign right there. Then additionally, I need to realize that tangent, if sine is positive and cosine is negative, then tangent is negative. And you don't even have to sit here and identify the quadrant you're in. You could just simply say, if tangent is sine divided by cosine, and I know that sine is positive and cosine is negative, then tangent has to be negative. So there are a variety of ways for you to figure out the positive or negative nature of each trig function with the information that is presented to you. Once you know the quadrants, you can ignore the fact that that is a negative 7/4 and focus on just secant theta being 7 over 4 and make a right triangle based on that. So I want to show you 2 ways you can go about it, and then you're going to pick what you like. If I ignore the negative sign, I'm going to put down ignoring negative sign. Then I want to remember that secant is cosine's reciprocal. Cosine is adjacent over hypotenuse. And then with Pythagorean theorem, I can come up with the length of this side. So 4 squared plus b squared equals 7 squared. 49 minus 16 will give me 33. And so I'm getting the square root of 33. Now, if I had done a reference triangle, then as I draw my unit circle, or actually it's no longer a unit circle in this case because I've got a radius of 7. So I draw my circle, and once I realize that I am dealing with a positive sine and a negative cosine, I draw some radius line in quadrant 2. I label that it's 7 because hypotenuse is 7. And then I drop a perpendicular down to the x-axis. I can see that the x-coordinate here is negative and the y-coordinate here is positive. And then I can remember that secant is, and here's my theta angle, I can remember that secant is cosine's reciprocal. So secant is hypotenuse over adjacent. And by doing that, I get that negative 7/4. And then again, I still have to do Pythagorean Theorem to get that this is root 33 and it's positive because y is positive. So either way, you just need to draw a triangle, a right triangle, and fill in its sides. Whether you deal with the negative numbers on the triangle itself or write down into your notes, hey, I know who's positive and negative, and just keep going, that's up to you. Once you get your triangle with all 3 sides, then you're going back to your SOHCAHTOA-ness. Sine is opposite over hypotenuse. We already have cosine. Tangent is opposite over adjacent. So I go to my triangle and I look at what is the opposite side, that is root 33. What is my hypotenuse, that is 7. For tangent, I'm looking at what is my opposite side over my adjacent side. My opposite side is root 33. My adjacent is, I can either look at it as 4, or I can get the negative out of seeing that it is negative 4. One way or another, this should be negative root 33 over 4. And once I have my sine, my cosine, and my tangent, I immediately have the 3 others. I'm now going to erase some of this work. Sine's reciprocal is cosecant theta. Cosine's reciprocal is secant theta. Tangent's reciprocal is cotangent theta. Now realize I was given secant in the first place, so I'm going to write it down. And now, reciprocating, I get 7 over root 33, and I get negative 4 over root 33. And I've got my 6 trig functions. So that is all that I'm asking you to do with these problems, where you're asked to find, if you have enough information to know what quadrant you are in, then all you need to know is one of your 6 trig functions, and you know what all of the other 5 trig functions are. If you write out a right triangle, use Pythagorean Theorem so that you have all 3 sides, and then you have all 6 of your trig functions right there. So that was item number 1. In your homework, that's going to be these problems, 1, 2, and 3. And at the bottom, I already have it set up nicely for you where you can fill in the remainder of your sine, cosine, tangent. I already have what was given information put into the answers, and their reciprocals are just right across the way. So I want to make sure that you understand that you can create all of this if you just remember SOHCAHTOA, sine being opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And who are their reciprocal trig functions? Sine and cosine's reciprocals are what we don't want them to be. So sine's reciprocal is cosecant, cosine's reciprocal is secant. But tangent and cotangent are also reciprocals, and that's easier to remember than the other ones. If you've got just that much information and you understand what I just said there, and you understand the issues with the fact that sine represents y, cosine represents x, tangent represents y divided by x. From there, everything should fall into place because you already know where x and y are positive and negative. You don't need to add anything to your memorization other than remembering that y is cosine, great, good job. Y is sine, x is cosine, tangent is sine over cosine. And then again, so ka, toa, and who are my reciprocals? Boom. Okay, next. The inverse trig functions are inverse functions. If you put inside of a trig function its inverse trig function, what should happen?
It cancels out.
Yeah. And so what should this answer be just with understanding what inverses do?
It should be 2 over 5.
You got it. That's it. Now, just to warn you, I'm not giving you a situation where we have the exception to the rules, and I'm not going to throw that at you. There is an issue that you have to be careful of because the inverse trig functions only deal with certain angles. But in this class, I'm not going to throw that your way. I want you to see that if you have a trig function and inside of it you have its inverse, they just cancel each other out. But what if you have inside your trig function somebody else's inverse? Then a little more work is required. If you are dealing with unit circle information, you can save yourself a little bit of time. In problem number 4, you're given inverse tangent of root 3. Inverse tangent will only give me an angle between negative pi over 2 and positive pi over 2. Do you remember what angle gives me a tangent value of root 3? And one thing I can say is your inverse trig functions have outputs that are theta itself. Normally, the angles are inputs of trig functions. So if you're working with an inverse trig function, then your angle is actually your output. And then if you realize that that inverse trig function is an angle, then you are working with actually the question of what is the sine of that angle. So where is root 3 when you're dealing with inverse tangent? And I need to make sure I can see chat. Oh, okay. Does everyone remember where we're going to find tangent of theta being root 3? And if you need to, maybe you need to rewrite it. This means the same thing as tangent theta being equal to root 3. And if you're remembering tangent theta as sine over cosine, then perhaps you notice when your sine is root 3 over 2 and your cosine is 1 over 2, you are at this particular angle, where there are two other special angles in that quadrant. Now, you don't actually need to know that angle. All you need to know is what is the sine of that angle. And the sine of that angle is the y-coordinate of that point, so it is root 3 over 2. The expression of what is the sine of the inverse tangent of root 3, that expression is equal to the number root 3 over 2. And that is it. That's that whole problem. And I just want to say again that these problems are easier if you're able to use the unit circle, but there are other ways that you can go about finding it, which I'm going to show you with the problems where we can't use the unit circle. Now I have this problem out because I want to remind you of the positive negative issues we're working with. This problem is very similar to number 4. The difference is we've got negative this time. So just like with number 4, we want to remember that tangent is only using angles between negative pi over 2 and positive pi over 2. When I'm dealing with negative root 3 for my tangent, that's going to send me to this angle right here. But realize you don't have to know the angle. You just need to know the sine of that angle. And the sine of that angle is the y-coordinate of that angle. And with the unit circle, things are in certain positions where you know that this is in the position of negative root 3 over 2. But I also want to mention, what angle is this if I'm using inverse tangent? And keep in mind, you have to use a negative angle. So what you really want to know is, if I go this far, 2/3 through one quadrant in the negative direction, when I go forward that amount, we're familiar with that being the angle pi over 3. So if I go backward that amount, my angle is actually negative pi over 3. So I wanted to point that out to you, just to clarify. And then for problem number 6, now we're getting out of unit circle. And this is where you might also use a reference triangle. But the thing is, you have to know for inverse cosine, what angle range does cosine use with its inverse trig function? You need to remember that inverse cosine is only using angles 0 to pi. I have a positive number going into my cosine, and I'm going to stay away from making these problems too complicated, so I'm not going to be throwing negative numbers at you. But with cosine being positive, with the ratio that is going in it, I want to say again, the answer to an inverse trig function is an angle. So part of this statement is that there is an angle for which the inverse cosine of 5/8 is that angle. By understanding what inverse functions are, I can also say that the cosine of that angle is 5/8 and see that I have a positive number for my cosine. If that had been negative, that would have put me in quadrant 2. But because it's positive, that puts me in quadrant 1. And now I need a triangle, a right triangle, where knowing cosine is adjacent over hypotenuse, I make a triangle whose adjacent side is 5 and whose hypotenuse is 8. So I'm just going to draw any old right triangle in any position. If you do the reference triangle, then you have to specifically draw that angle so that you're using the x-axis, the angle, and then where you intersect a circle, and it's no longer the unit circle, you drop a perpendicular down. And it's no longer the unit circle because I'm dealing with a hypotenuse that is 8, and the unit circle always uses that hypotenuse as 1. Now cosine, again, is the adjacent side over hypotenuse. And just like before, we can find our third side, if we need to, using Pythagorean theorem. So let's just call that length B. And I'm going to put over here, same thing. So what I have is 5 squared plus b squared is equal to the radius squared. Understand you don't have to draw both of these triangles, you just need one of them. You don't have to do a reference triangle. You can just do a regular triangle, but I'm going to erase this so that people don't think that they have extra that they need to do. It's just you can choose to put this in its reference point, or you can leave it as just any old right triangle in any position you want, understanding who's adjacent, who's opposite, whose hypotenuse. And I'm sticking with positive numbers to not go in too deep in this. So I have 25 plus b squared equals 64. 64 minus 25 will give me 39. Double check my subtraction. Tell me if I'm wrong, because I'm pretty sure I'm right, but I'm also make mistakes sometimes.
I got the exact same answer.
Yay, thank you. And so this gives me that b is equal to the square root of 39. And square root of 39 can't be simplified. It's 3 times 13. So I can't pull any perfect squares out of it. I'm going to put down that the length of this side is the square root of 39. And now realize that the problem's actually just asking you what is the tangent of theta. And tangent is the length of the opposite side over the adjacent side. So the answer is root 39 over 5, and that's the entire problem. So let me just recap and explain to you how little you need to do. I'm going to erase the whole thing and do a recap. You see inverse cosine of 5/8. That is an angle. If you're using inverse cosine, then you know you're only dealing with the top half of a circle, and you're only allowed to use the angles that go between 0 and pi. And I'm just throwing in pi over 2 to just have it there. Now, my cosine is either positive or negative. This is a positive ratio. So that means that I'm going to draw a triangle in quadrant 1, not in quadrant 2. And that's the difference between this being positive versus negative. Then you can draw a reference triangle or any triangle where you use the x-axis as part of the angle. The hypotenuse is the other part of the angle. Cosine is adjacent side over hypotenuse. Using the Pythagorean Theorem, I can get that this side is the square root of 39. And then all I need is the tangent. And the tangent is opposite over adjacent. Done. That's all you have to do. And that gets us through the entire classwork. Woohoo! Now, I'm going to stop the recording.